For this lesson, we're going to summarize and further investigate rational exponents. So just doing a quick review of our product laws. If I have x to the m times x to the n, I have x to the m plus n. If I have x to the m divided by x to the m, it is x to the m minus n. If I have a power of a power, then it's x to the m multiplied by n. If I have a power of a product, then it's x to the m and y to the m. The quotient of a power is x to the m over y to the m. If I'm doing a negative exponent, it would be 1 over x to the power of m. And if I'm doing a rational exponent, it's going to be the n root of x to the power of m, which could also be written like this. So, to begin with, we're going to write each power as a radical. This would be the same as the sixth root of x. This one, I'm going to leave the negative on the outside, so be careful about that, and say that it's going to be the fourth root of y to the power of 5. This one has brackets around the negative, so the negative has to go on the inside. This is the same as the cube root of negative z to the power of 5. The negative exponent for this one is going to make this 1 over negative z to the power of 5 over 3, which we know is the same as 1 over the cube root of negative z to the power of 5. For example E, be careful that 5 is a coefficient. It's not part of the base. So I have 5 times the fourth root of t cubed. In this case, that 5 is part of the base. So I have the fourth root of 5t cubed. If I'm simplifying where I'm multiplying or dividing rational exponents, then I need to remember that I'm going to be adding or subtracting fractions. This is the same as x to the 3 over 2 plus 1, which would be the same as 2 over 2 if I put it as a fraction with the same denominator. So this is the same as x to the 5 over 2 or the square root of x to the power of 5. In the second case, when I'm dividing, then I have y to the 1 over 3 minus 5 over 3, which is the same as y to the negative 4 over 3. I'm going to make the exponent positive by saying it's going to be 1 over y to the 4 over 3. And we know that's the same as 1 over the cube root of y to the power of 4. For example C, I'm going to be multiplying, so I'm going to multiply straight across the numerator. 1 times 2 is 2. And 2 times 3 is 6. And 2 over 6 can be reduced to the fraction of 1 over 3. So this is just the cube root of a. For example D, I'm going to get rid of the negative exponent first. So I'm going to take the reciprocal and say that y goes on the top and x squared goes on the bottom. And these are to the power of 1/2, which means that I'm going to have y to the 1/2, and x squared times 1/2 is going to be 2 over 2, or just x. And then say that's going to be the same as the square root of y over x. For example 3, all we've done is add coefficients or more complex bases, but our process is still going to be the same. So in the first case, I'm going to deal with the coefficients separately. 4 times 3 is going to give me 12. And then x to the 3 over 4 plus negative 1 over 2, well, those don't match. So I'm going to say it's going to be x to the 3 over 4 plus negative, and I need to multiply the numerator and denominator of this one by 2 to make it have the same base. 2 over 4. That's going to give me x to the 1 over 4 is left, or 12 and the 4th root of x. For example B, the coefficients are going to wind up being reduced down to 1/5. I have x to the 5 over 3 minus negative, 3 over 5 minus negative 3 over 5. So that's the same as adding it. So I actually have x to the, when I add the numerators because they have the same denominator already, 6 over 5. Well, I can leave the x on the numerator and say that that's going to be the same as the 5th root of x to the power of 6. And when I multiply that by 1 over 5, I just have a 5 in the denominator. For example C, don't forget, this exponent is going to apply to the 8 as well. So what I have here is the cube root of 8 to the power of 4, and that's being multiplied by a to the power of 1 times 4 is 4, and 2 times 3 is 6. And I'm going to reduce and simplify this. I'm going to say the cube root of 8 is 2, which is to the power of 4, and I have a to the power of, this is a reduced fraction, is 2 over 3. So 2 to the power of 4 is going to be 16, and a to the 2 over 3 is the same as the cube root of a squared.